So welcome to all of you. Now we'll see the Runge Kutta method for solving the ordinary differential equation of order 1. Okay. So consider the differential equation. Consider the differential equation dy by dx is equal to f of xy with initial condition y naught. Okay. So we want to find the solution of this differential equation. Okay. So we will solve the differential equation 1 for the values of y at x is equal to xr x naught plus rh r is equal to 1 2 3 dot dot dot. Okay. So now we'll integrate this as usual. This is dy by dx is equal to x naught to x f of xy dx. Okay, so we know that this is same as y1 minus y2 x naught to x f of xy f of x1 x naught to x1. Okay, x naught to x1 dx. Okay, so this is what y1 is equal to y naught plus. Okay, so integration from x naught to x f of xy dx. Okay, so by trapezoidal rule, same thing as usual formula. Okay, so by trapezoidal rule, y1 is equal to y naught plus h by 2 f of x naught y naught plus f of x1 y1. Okay, plus f of x1 y1. Okay, so we'll choose y1 is equal to y naught plus h f of x naught y naught. Okay, so then y1 is equal to y naught plus h by 2 f of x naught y naught plus f of x1 y naught plus h f of x naught y naught. So this is same as y naught plus h by 2 f of x naught y naught plus f of x naught plus h y naught plus h f of x naught y naught. Okay, we call this as 1 now. Okay, if k1 is equal to h f of x naught y naught, then okay, so k1 is equal to this, and we put k2 is equal to f of h f of h x naught plus h y naught plus k1 then see y1 is equal to y naught plus h by, this is 1 by 2, not h by 2, this is 1 by 2, this is h f naught y naught plus h f of x naught plus h y naught plus h f of x naught y naught. This is complete. Okay. Now the y1 is equal to y0 plus 1/2. So now h x f of x naught y naught is nothing but this is x naught. This is your k1 now. Plus now this is h. This is your y naught plus k1 now. This is so this is what is k2 now. This is k2. Okay. So this is called the second order Runge-Kutta formula. Okay. So remember this. So for this you have to remember this k1, k2, this 1/2. This is the formula. Okay. So k1 you have to remember h f of x naught y naught, and k2 is equal to h f of x naught plus h y naught plus k now. Y naught plus k. X naught plus h, y naught plus k. See, this is y naught plus, this is k1. Oh, y naught plus k1. Y naught plus k1. Okay, so this you have to remember only. Y1 is equal to y naught plus 1/2, k1 plus k2, and this. Okay. So you may write this is what k2 is equal to. This you can find k2 now. This y2 now. Y2 is equal to y1 plus 1/2. K1 plus K2. You will write this as your K1 will be what then? K1 is equal to h f of x1 y1 then. Okay, and your K2 is equal to what then? H f of x0. X0 is x1 now. X1 plus h, x1 plus h, y0 plus y1 plus k, y1 plus k1. Okay, so this will be your y2 now. So you can solve this by Euler's theorem. By Euler's method, the same thing here, y2, y1, y2. This is your y1. You can find your y2. You can find similarly y3. You can find your y4. You have to take the care of this one. Okay. So now we will just write the fourth order formula. Okay. The fourth order formula. Just we write that formula because we don't want the theory. So we write that formula. Okay. Runge-Kutta formula for fourth order. Just we write the formula because we don't want anything now. Just we have to apply the formula. That is y1 is equal to y0 plus 1/6 k1 plus twice k2 plus twice k3 plus k4. Okay. You have to write only the formula now here. Your k1 is equal to h f of x0 y0. Your k2 is equal to h f of x0 plus h by 2 y0 plus k1 by 2. Remember this is k1 by 2. Now your k3 is equal to h f of x0 plus h by 2. x0 plus h by 2, x0 plus h by 2. Listen, this is what? y0 plus k2 by 2. Now here what? If you don't get k2, you will not get k3 now. Okay. So now k4 is equal to h f of x0 plus h y0 plus k3. Okay. So this is the formula. For y1 is equal to this. This is the fourth order formula. Just remember this. Remember the values of k1, k2, k3 and k4. This is only important. y1 is equal to 1/2 k1 plus twice k2 plus twice k3 plus k4. The values of k1, k2, k3 and k4 are also important now here. So here what? x0 plus h by 2, y0 plus k by 2. Both are the same now here. Your k1 is same as the previous one. Okay. So this is what here? x0 plus h, y0 plus k3. Your fourth. So this is very easy now. Easy to remember. The formula for k1, k2, k3, k4 now. Okay. So for y2 is y1 then 1/6 this same as Here K1 will be what then? H f of x1 y1 then. K2 will be what? H f of x2. Here x1 plus y1 K1 by 2. Okay. So we get K1 now here. K3 will be what? X1 h by 2, y1 K by 2. Right. So for y2 you can do this one. Okay. So I hope that you understand this rule. The formula. This formula is important now here. Okay. So this is the formula. Okay. Along with K1, K2, K3 you can remember this. Okay. So this is the theoretical part. We will solve a problem so that you will understand how to apply this Runge Kutta second order formula or fourth order formula. Okay. So we'll take a problem. Solve dy by dx y minus x y of 0 is equal to 2 by Runge Kutta formula with h is equal to 0.1 and compute y of 0.1 and y of 0.2 correct to 4 decimal places. Okay, solution. Given that dy by dx y minus x y of 0 is equal to 2, x naught is equal to 0, y naught is equal to 2, h is equal to 0.1, x1 is equal to 0.1, x2 is equal to 0.2. You have to find y2 now. Okay. So just we write the formula for y1 is equal to y naught plus 1 half k1 plus k2. This is the formula. Okay. So your k1 is what? H f of x naught y naught, and your k2 is what? K2 is h f of x naught plus h y naught plus k1. Okay. So we find k1 now. K1 is equal to h is what? 0.1. So f of x naught is what? X naught is 0 and this is 2. So 0.1 into f of 0 2. So here you have to write f of xy. F of xy is equal to what? Y minus x. Right? So 2 minus 0. So 2 minus 0 is what? 0.2. Okay. So K2 is what? 0.1. Okay. So we'll find f of x naught plus h. Your x naught is 0. Your h is this. So x naught plus h is 0.1. Y naught plus k1. Y2 is 2. So 2.2. This is 2.2. So 0.1 into what? Y minus x. So 2.2 minus 0.1 minus 0.1. So this is 0.1 into 2.1. Right? So this is what? 21. So 0.21. Your K2 is what? 0.21. Okay. So now we put here y1. So y1 is equal to y naught is what? 2 plus 1 half k1 plus k2. Your k1 is 0.2 plus 0.21. So 2 plus 0.1 plus 0.110 105. So this is what? 2.205. 2.205. This is your y1. That means this is y of point 1. Y of point 1 is equal to 2.205. Okay. Now we have to find y2 also. So y2 is equal to y1 plus 1 half k1 plus k2. 1 half k1 plus k2. Okay. So now your k1 is, okay, just we will write now k1 also. K1 is equal to h f of x1 y1. Okay. So h is 0.1. Okay. F of x1 y1. So f of your x1 is 0.1. x1 is 0.1. Your y1, just we have calculated y1, that is 2.205. So this is what? 0.1 into 2.205 minus 0.1. So this is 0.1 into 2.105. 105. And this is what? Just we will take the product. 2105. Okay, this is the product. Then you have to left the 4 decimals. So this is what then 0.2105 is your k1. So now k2 is equal to what? H f of x1 plus h y1 plus k1 now. So 0.1 into f of x1 plus h. Your x1 is, this is 0.2. So f of, okay, so f of 0.2, f of 0.2, okay, y1 plus k1, y1 plus k1, this is your y1, y1 plus k1, y1 plus k1 is what? 2.4155. Okay, so now this will be equal to 0.1 into 21455 minus 0.2. So this is what? 0.1 into, so 2.2155. So product is 22155. You have to left the 5 now. Okay. So this is your 0.22 this. Okay. You get k1 and k2. So your y2 is equal to y1. Y1 is what? 2.205 plus 1 half k1 plus k2. What is your k1? Your k1 is 0.2105 and your k2 is 0.22155. You may take the addition and then you can divide by half. So this will what then? See, this is what? 0.2105. And this is what? 0.22155. So this is 5, 0, 1, this is 2, 3, 4, this, okay. So 0.43205. And we divide this by 2, then this is what? 2 here, okay. Then 1, then 6, then 0, and then 2, and then 5, okay. So now this will be, see, this is what? 2.205 plus 0.216025, right? So addition will be what? 0. So 1, this is 2, this is 4, 2.421025. This is your y of 0.2 now. This is your y of 0.2 is equal to 2.4210. Okay. So up to 4 decimal places. So this is the correct value. 2 point this. Okay. So we get correct value of this one. So similarly you can solve the number of problems. Similarly you can solve the number of problems. You can solve this by fourth order formula also. If the crucial part is only what? We have to find the values of K1, K2, K3 and K4 and so on. Okay. So here the crucial part was what? You have to find the values of K1, K2 and so on. I hope that you can solve the number of problems on it. Okay. So it is enough to solve one example. With the help of this example, you can solve the number of problems. Only the crucial part is what? To write a formula for K1, and K2 only. Okay. So and for Y2 you have for Y2 also the crucial part is what you have to write the correct formula for K1 and K2 and so on. If you want to find the Y of 0.3, then also you have to find the Y3. So for Y3 you will need the K1 and K2 also. So the formulas of K1 and K2 just I told you. So for Y2 this is what K1 and K2 you are using. Similarly for Y3 your K1 is what f of x2 Y2 then. Okay, and your K2 is what x2 plus h Y2 plus K1 now here. Okay, so that is the formula for K1 and K2 for this. Okay, similarly you can do for Runge Kutta fourth order formula also. Okay, so it is very easy now. I hope that you can solve this. Okay, so now we will stop here, and this is the end of the numerical analysis, that is the paper second. Okay, so we will stop here. So try to solve the number of problems. If you have any difficulty, you can come and ask me. Okay, or you can phone me. Okay, thank you.